Got it. Okay, we are recording. So we're going to do just a little review on test 5, which is sections 7.1 through 7.4. So the main concept here really is the foundation of radicals. So we're simplifying radicals. We're going to show how to go back and forth from a radical to an exponent. And then we're going to do some addition and subtraction of radicals at the very end. So let's start in 7.1. We'll go section by section here. So 7.1 is really on simplifying radicals that really have perfect roots, perfect squares, and also how to do this in your calculator. I don't think we haven't talked much about it in the morning sessions, but it's also about, knowing how to put these in a calculator is important as well moving forward. So if we looked at, we'll just start there. So section 7.1, the very first thing is just approximating roots. And the funny part is I don't have a calculator in this room. I think I let my son borrow it to take the ACT. And like many things, once something is borrowed, it did not come back. But I'll give you some examples to try. Like if we had, say, just the square root of 7, something like that, the square root of 7. I know like 2 squared is 4, 3 squared is 9. So it's got to be somewhere between 2 and 3. So I want you real fast, help me out, you guys that are in the class. Pop that in your calculator and just round it. Your book rounds it to 3 decimal places. And just put it in the chat for me. That way we can kind of see if we all got it right. It's going to be 2 point something. Yeah, just pop it in the chat. Oh, I need one more decimal place. If it's 0, that's fine. I just need one more decimal place though. I need 3 decimal places. Okay, perfect. 2.645. You guys agree, Jamie and Gracie? Okay. 2.645. So just knowing how to pop it in your calculator and then pop out an approximation. And I know that hopefully this is the easiest question on the test, right? It's just being able to use the calculator to get a square root, because sometimes we're going to need to approximate the number and not just use the radical. Because if I told someone, hey, oh, the length of that whatever is the square root of 7 inches, that doesn't make much sense, right? But if I said, hey, it's about 2.645 inches, they'll go, oh, okay, yeah. Why did you use so many decimal places? But whatever, at least they get an idea of how the length, okay? So next is going to be simplifying roots that have nice simplification. Square roots and cube roots. So if we look at, let me be sure I'm not getting, yeah, it'll just say like find each, let's say root. Some will be cube root, some will be square root. So 2, we could do like, let's say, the square root of, like 49, something like that. 3, we'll kick it up a little bit and we'll say, what if there's a number out here? What if it's like 2 cube root of 8x to the 12th? Okay, let's look at these two. So the square root of 49 is nice, right? And I'm going to go a little deeper into this than I have to. But the reason this is 7, really there's a square there, right, is because 49 we can write as 7 squared. And because the square root and there's a square in the radicand, those cancel, and that leaves us with the 7. Okay, you don't have to, of course, write all that down, but that's really where it's coming from. Now, on the number 3 here, we've got a 2 hanging out on the outside. Now, remember, if we take anything out, we've got to multiply it by that 2. So, yeah, and it turns out we can. The cube root of 8, look, I can write 8 as 2 cubed. It's 2 times 2 times 2, right? So, therefore, the cube root of 8 is just 2. So that 2 is already there from outside. This 2 is from the cube root of 8. And then the cube root of x to the 12th. Well, remember now with exponents, with bases, we're going to see how many times this root goes into the exponent. 3 goes into 12 4 times. Evenly, right? There's nothing left over. There's no remainder when we do this. So, and the 8 had a perfect cube root. So there's no radical left over. So this becomes 4x to the 4th. Okay? I'm not forgetting anything. Oh yeah, we'll do a few more. A few more of these that kind of throw in a lot of stuff here. So 1, 2, 3. Let's do number 4 here. Let's do one that's a fraction. So if we did, let's say, the cube root of 27 over 49. Wait, is that cube root? No, that's 64, guys. Hold on. Cube root of 27 over 64. This is like number 28 in your homework, okay, from 7.1. So the cube root of 27 over 64. Now look, I'm going to use a rule that they didn't really bring up until 7.3, which I thought was kind of different, but they should have introduced it earlier. So remember, we can take the cube. This means, I should say, we need to take the cube root of the top, and we need to take the cube root of the bottom. Now, I'm going to show you how to pop this in your calculator if you're not sure on how to do cube roots, because there's not a cube root button. But if you take that number, let's say 27, you're going to have a caret button in your calculator. It looks like a caret. I say it doesn't look like a carrot like you eat, but it's a caret symbol. Okay, a caret symbol. And then you need to put parentheses. And we're going to write this like we do in 7.2. We're going to write it like an exponent. Remember, the cube root of 27 is 27 raised to, that's what the caret means, 1/3. So if you put it just like that in your calculator, it should pop out 3. Okay? So it's just a way to put any root in your calculator is by making it an exponent, which really we get to in the next section, right, in 7.2. So try 64. Do the same thing for 64. 64 raised to the 1/3. And then tell me what you get in the chat button. Because it's not 8, because the square root of 64 is 8. Let me know in the chat what you get. Yes, perfect. Perfect. Yeah, you get 4, which makes 3/4, right? You get 4. So the cube root of 64 is just 4. And that's nice stuff to kind of have in your back pocket. So you don't have to do the factor tree or things like that, right? You can pop this kind of stuff that has nice cube roots and square roots and fourth roots. You can pop those in your calculator just to check to see if it's a nice number before you have to run that factor tree from this section, right? Okay, let's do one more. Let's do one that I love putting on the test. I'm not saying it's going to be on the test, but I'm just going to say that I commonly put this type of question on the test, where I do the square root of negative 36x to the 12th, something like this. Negative 36x to the 12th. Okay, what's the answer? You can yell it out if you want. Scream it in the microphone. Or what do you think it is? Yes, Gracie, yes. It's non-real, right? Again, and I know I've kind of preached on this this week. I need your brains to realize this is non-real. And it's because we have an even root, the 2, and we have a negative under the radical. So non-real. This is going to be a non-real answer. And again, once we get to 7.7, section 7.7, and next week we'll talk more about those. We spent a whole section just talking about non-real stuff. Okay. Cool, cool, cool. So any questions? This is all 7.1, probably a little deeper than I had to go into it, but it's a good good review of 7.1. Any questions before I flip on over to 7.2 or not? There we go. I'm trying to get to the bottom. There we go. 7.2, which really introduced kind of the Rosetta Stone between the radical and the rational. They call it a rational exponent because the word rational in math means fraction. Okay, rational exponent. So at first, I'm just going to want you to go back and forth. And we talked a little bit this, if you were in the class yesterday morning, we talked a little bit about doing this, like going one way or the other. So writing something in rational or writing it in radical. I'm going to follow your book. Your book says first, use radical notation to rewrite each expression and then simplify it if possible. So if we had, I'm going to steal one. This is like number 9 in your homework. 2m to the 1/3. So for this example, just write it in radical notation. And if you can simplify it, simplify it. Let's do another one. Let's say we had, this is like number 18. 4 to the 5/2. Actually, I'm going to be even trickier, and I'm going to say 4 to the negative 5/2. So let's do these. It's okay if you want to kind of work ahead a little bit and try to do them. So we get 2. Now, look, this m to the 1/3 is only on the m. It is not on the 2. 2 is really only being raised to the first power. If I wanted the 2 raised to the 1/3, I'd have to use parentheses. So this becomes 2 cube root of m. And that is straight from the homework. It's number 9 on 7.2 in your homework. So 2 cube root of m. Now number 2, though, I kind of stole and changed from the homework. So we got 4 to the negative 5/2. So first off, I have to get rid of the negative first. Remember, with our rules, you pop it into the denominator. And now I'm going to change this to radical notation. And I'm going to do this because, look, the bottom is a square root, right? I'm going to do the square root first and then raise it to the 5th power. You can do that. If you go back to the rules about going from one to the other, you're more than welcome to do that. So you wind up with 1 over 2 to the 5th, because the square root of 4 is just 2. And then we raise it to the 5th power. And I think we said 2 to the 5th was 32 earlier in this lecture. You can check me on that one and let me know if I'm wrong. But I believe it is 32. Okay. Okay. Any questions about those two? It's more about going back and forth, right? One or the other. And then your book then goes over, simplifying these. Now, so really, this is just an exercise in simplifying. Simplify. And then it says using properties of exponents. Simplify using properties of exponents. So let's look at one. I'm going to steal one. We did some of these yesterday too, but let me steal kind of a straightforward one. Like number 44. We've got y to the 4/3 times y to the negative 1/3. And then we'll do a more complex one. Like 49 here, 4u squared raised to the 3/2. And then we'll do one more. Let's steal one here. I don't remember which one. Oh, yeah, I do. Let's do a real complex one here on number 5. And I might need another piece of paper actually for this. Let's do m squared. This is number 58 in your book. m squared n to the 1/4 over m to the negative 1/2 n to the 5/8. Okay, so let's start on the basic one first. So y to the 4/3 times y to the negative 1/3. Oh, look, we've got to add these, right? Because they're being multiplied. And what's really nice is these have the common denominator. If they've got the common denominator, we just have to add the numerators. So this becomes y to the 4 plus a negative 1, so 3 over 3. So this becomes just y to the first power. So it's just y, okay? Just y. It's really easy to add these fractions, right? Whenever there's a denominator, the denominators are the same. So number 4, I've got to distribute that 3/2 into both of these. So remember, the 4 has a 1 on it. So it's going to be 4 to the 3/2 times u. Now, 3/2 times 2, remember, it's really like 2 over 1, right? You multiply the tops and the bottoms, so you get 6 over 2. Hey, that's not bad. So it'd be 4 to the 3/2 times u cubed. 6 divided by 2 is just 3, right? Now look, you're more than welcome to do what we did up here for this number 4, but you could also pop it in the calculator and just do. So in the calculator, real fast, do 4 raised to 3/2 and tell me what you get back. Just pop it in the chat. Tell me what you get. 4 to the 3/2 and tell me what you get back. Oh, this is number 49 on in the homework. $2.3. I don't think it's going to be 2.3. Make sure you close this. You make these parentheses, Gracie. So it's going to be 4 caret 3. And then if you're using that TI-80, whatever, you're going to, make sure this whole thing's in the exponent. 8, that's closer. That might be right. Yeah, that's it. That's it. So it's 8 u cubed. Yep. Make sure you get 8, Gracie. Did you get 8 that time, Gracie? Give me a thumbs up. Okay, good. 8. So yeah, it gives you an 8. 4 to the 3/2 is just 8. Okay. And now this last one, let me see if I can. All of my black markers, the tip is getting. Let's see if we can pull out a new man. It's time to go buy some new markers. Okay, this red one, the tip is a little finer, so I can write a little bit smaller to do this one. Okay, we'll zoom in here, and I really don't have to write that hard. Okay, so now this was the number the on the page. So let's bring in the 1/4 first. Let's get rid of the parentheses. So 2 times 1/4. Now look, I'm going to be a little lazy here. 2/4 is a half. So this is going to be m to the 1/2 times n. Now n is really raised to the first power, so it's going to be n to the 1/4. Okay. And then we still have m to the negative 1/2 down here, and n to the 5/2 or 5/8. Okay. Now the m's won't be too bad. Look, if you subtract 1/2 and negative 1/2, you're adding them, right? 1/2 minus a negative 1/2, that's 1/2 plus 1/2. Well, 2 halves, when you add them together, they equal a whole. So this is going to be just m to the first power up top. 1/2 minus a 1/2 is that 1/2 plus 1/2. It's just 1. Now the 1/4 minus the 5/8, though, I'm going to do this one with the happy cyclops. Okay. 8 minus 20 over 32, right? 8 minus 20 would be negative 12 over 32, which winds up with, these aren't divisible by 12. They're both divisible by 4, though, correct? So this is going to be negative 3/8, right? Negative 3/8. So let me make sure, yeah. Negative 3/8. So we get n to the negative 3/8. And now I've got nowhere to put my answer. Okay, hold on. Let's sneak a little extra room over here. Look at that. So therefore, this would equal, now I've got to move the negative down to the denominator. So it's m over n to the positive 3/8. And that's my solution there. Okay. And now in this one, it does say to leave it in positive exponents. Okay. Leave it in positive exponents. Don't put it in to roots. If we did that, this would be the 8th root of n cubed. But it didn't ask us to do that there. Okay. Zoom out here. Any questions from 7.2? So these are all good questions that could be on 7.2, all 5 of them. A good review from this section. Okay. Okay. 7.3, which was really the introduction of simplification of radicals, right? This is when we really started simplifying the radicals. Like in 7.1, it was very specific types of radicals that simplified nicely. In 7.3, they're all over the place, right? And I introduced the factor tree method. If you know the other way, just do the other way. That's fine. But I introduced the factor tree method, so I'm going to start there. So let's say we had, this is 7.3, simplify radicals. So let's say we've got the square root, number 1, the square root of, I'm going to give you these like a quiz, and I want you to work them out, okay? So I'm going to give you a little time, and I want you to work these like a quiz, unlike those previous ones that I kind of did them as we went along. Let's say the square root of, or cube root. Let's do cube root of 108, number 1. Number 2, let's do, do like a mixed review here. Let's say we've got 3 square root of 12y to the 5th. That's a good one. So 3 square root of 12y to the 5th. And then number 3, let's do, oh yeah, I see what they're doing. They're going backwards here. Let's say we're going to do 7. This is number 66 in your homework. I'm stealing this one. 7 4th root of 162 over the 4th root of 2. We'll do one more. Let's do just 4 from this section. Yeah, we'll do one of those basic ones from the very beginning. Let's say, yeah, let's say we do the 4th root of y over 81x to the 4th. So this one is the 4th root's over the whole thing. So try those 4. I'm going to give you a few minutes, about 5 minutes, just to get those done. And it's okay if you're not completely done. get these done. So the cube root of 108, if you pop in your calculator and try to do what we did earlier, right? 108 to the 1/3, you're not going to get a clean answer. You shouldn't anyway, unless you got a special kind of calculator. Let's pop the 108. Let's make this happen. So 54 times 2, right? So the 2 is good. 54 we know is 27 times 2. 9 times 3. 3 times 3. Okay, we got a lot going on here. But we have to remember that we're trying to get a cube root, right? So therefore, we're looking for 3 of a kind. And we've got 3 of a kind 3s here. So because we have 3 of a kind 3s, we can take out the 3. We just need one more 2, right? And we just don't have it, and that's fine. So therefore, the 2s, both the 2s have to stay under the radical. So it's going to be 2 times 2, so 4, under the radical. Okay? Questions about that one? So now on this next one, we need to do the same thing with the 12. I'm going to write it under here because it's kind of a blank space now. So let's do 12, 6 times 2, 3 times 2, right? Now, what's different about this one than the first one is that it's a square root, right? We don't have to write it, but it is a square root. So therefore, we're looking for pairs. And we got 2 2s. And now this 3 is going to have to stay underneath. But now there's already a 3 out here. So when we take that 2 out, remember we have to multiply by the 3 that's there. So this becomes 6 square root of 3y to the 5th. Now we're going to have to handle the variable, but just with the numbers, when we take the 2 out, it's going to multiply by the 3, so it gives us a 6. We've got the 3 left over, so it stays underneath, and y to the 5th, right? So now we have to deal with the y. Remember, it's a 2, so how many times does 2 go into 5? 2 times, right? And we're going to have 1 remainder. So 6y squared, 3 square root of 3y. Any questions, comments, or concerns on that one? Especially if I did something wrong, let me know. Okay, so let's look at this.
I'm sorry.
Oh, no, you're fine.
Okay, so I thought since there was already a 3 outside of the radical, like the coefficient was 3, and then you divide 12 by 2, and you get 6 left over, right? And then
I don't. Hold on.
Somehow I got 18.
Hold
I'm
on.
sure I'm wrong, but
No, that's I think you're kind of overthinking it. Like it's whatever.
Okay.
Whatever is the pair here is coming out, and when it comes out, you're going to multiply it by that coefficient.
Oh, I didn't factor it out. I just divided. So yeah.
Oh no, yeah. Do not do that. Do not do that. Yeah. No. I see what you're saying. Yeah. No. Don't do that.
Okay. Thanks.
Yeah, no problem. Yeah, you've really got, and you got to think like JL. This isn't an equation, so it's not like if you divide on the inside, you also have to divide on the outside. It's not an equation. It's an expression. So you can't just start doing that kind of stuff like that. Right. Yeah. It's a good question, but that's why. It's because it's just a term really. Any other questions? That was a good one. Any other questions? Okay, let's go to this next one. Now look, the trick on this next one is that because they're the same, you can divide. And now, of course, I told JL, you can't just divide things out of willy-nilly. Well, this one was written in. Okay, this is written in. And because it's the same, you want to divide it first. Oop, 2, not 81. Okay. So we want to divide, because it's the 4th root on top and bottom, we're going to divide these into 1 radical. Now that 7 is just going to hang out the whole time. We get the 4th root of 81. Okay. So 62 divided by 2 is just 81. Now look, let's check to see if 81 has a 4th root. I know it does, but we're going to use our calculator. Okay. So pop in the 81 caret 1/4 and see what pops back. You can use your fingers. I can see JL and Gracie. Yep, 3. It's just 3. So we wind up with 21. Okay, we wind up with 21. Questions about that one? The rule that it's going over is that, look, if you've got the same root on top and bottom, you can divide it together. Okay, if it's the same root, the fourth root for this one, then therefore it can come together as 162 divided by 2, which makes it just the fourth root of 81. Okay, now the other one's kind of the vice versa. This one is like, okay, well, if we can combine it under 1, that means we can separate it as well. So this would become the fourth root of y over the fourth root of 81x to the fourth, right? So if we can do this, if we can combine, we can also separate, okay? Now, the fourth root of y, we can't do anything with, right? Remember, it's how many times does 4 go into 1? Well, 4 doesn't go into 1. So we're done there. But this denominator is going to simplify nicely. And I'm going to be a little efficient here and say, we already know the fourth root of 81. We just said it was 3, right? So the fourth root of 81 is 3. And look, for this one, how many times does 4 go into 4? 1 time. So it just becomes x to the first power. And notice there's nothing left over because the fourth root of 81 is a clean radical. And so is the fourth root of x to the fourth. So we're done. That's it. I don't know where that 7 came from.
Wait, can you hold on?
That's a y.
Oh, okay, that's a y.
Yeah,
Okay.
I don't know why I wrote 7.
Yeah, I was about to get confused.
Yeah, that was really confusing. That's some new math we haven't gone over yet. No, I'm joking. I don't know. That was just a goofy mistake. That was it's 8:50 in the morning mistake. Okay, do you guys in the class right now have any questions from 7.3 or from any other questions in the 7.3 section? These are 4 good questions from 7.3. I'm just making sure I haven't missed something. Yeah. Okay. So now let's do 7.4, which is add, subtract, multiply these radicals together. 1 second. Hold on. Well, that's weird. Okay. So let's do a few. So 7.4 is really about adding, we're going to be a little late, adding, subtracting, and multiplying radicals, right? Adding and subtracting and multiplying radicals. So let's start with just the addition of some of these. Let's say we had, let's do one with just numbers here. I bet there's like a mixed review somewhere I can steal one from. Probably after 7.5, yeah. Okay, I'm going to steal. This is on page 552. It's a review. And I'm going to steal some from it. Let's say we've got the square root of 20 minus the square root of 75 plus 5 square root of 7. Do that one. And I'm only going to do like 2 per page here because it kind of takes up a lot of space. So let's do number 2. We'll do a subtraction one. Why not? Well, actually, this has addition and subtraction. Let's just throw a multiplication in. Let's say we've got 2. I'm going to make one of these up. 2 squared of 3 minus 4 squared. Okay. So let's look at this first one. Well, I'll work through it with you. We won't treat it like a quiz. And that way, if you have a question, you can just ask me as we're moving along. Okay. So square root of 20, let's break it down. So 20, it's going to be 10 times 2, 5 times 2, right? So I can pull out a 2. So I'm going to write it over here. This way it gives me some room to do the simplification. So I'd have 2 square root of 5. That's what the square root of 20 would be. Okay, 2 square root of 5. So now let's do the 75. 75, I know is what, 25 times 3, right? 3/4. And then 5 times 5. So for the 75, again, it's a pair, right? It's square roots. I've got a pair of 5s. Now I got to leave that 3 underneath there. So it's going to be minus 5 square root of 3. Now the 7 is a prime number. I can't simplify it. So plus 5. Oh, they got tricky with this one, didn't they? I'm going to have to do another one. Actually, I think on the next one it kind of covers it. Can I add any of these together? No, I can't, right? Now they all have the same root, but all 3 have different radicands. 3, 5, and 7. I am stuck here. I cannot add those together. This would be my final answer, okay? That would be my final answer. Not a great example, but it's not a horrible one because you kind of see why. The next one will get some addition in the multiplication, but you can see, hey, we don't have that going on. We can't do that, okay? We cannot do that. So let's look at number 2, which is really multiplication. And I chose this one because one of my number 1 pet peeves, and I shouldn't call it pet peeve, it's a very common mistake students do in algebra is when they see this squared, automatically they bring it into both terms. But we cannot do that because it's a minus sign there. If it was just the 2 squared to 3 squared, we could. But because it's the minus sign, we have to FOIL. We have to FOIL this out. Remember back in 5.1 or 2 or something, we talked about distribution, Lord. Okay, so now we're going to multiply, and this is multiplying radicals together, okay? I'm going to multiply 2 squared to 3 times the 2 squared to 3. Now, we can only multiply if the roots are the same, which they are, right? Square roots. So then we multiply the coefficients, 2 and 2, so that gives us 4, by the radicands, or underneath the radical. 3 times 3, that gives me 9, okay? So 2 square root of 3 times the 2 square root of 3 would give me 4 square root of 9, which will simplify quite nicely, but that's the first. The outside, well, look, we've got an integer without a root, and we've got a radical term. Look, you can multiply these. It's not like addition or subtraction where you have to have the same root and radical. It's just that the coefficients will multiply. The -4 is going to multiply by the 2. So you wind up with -8 square root of 3. Think of it like 2x times -4. You'd say, oh, well, that's just -8x, right? It's the same idea. The radical is like a variable in a lot of ways, okay? You can just multiply. It's not like a variable. Ugh, this is recording. I'm going to get an email from a math teacher saying, no, it's not variables. The radicals are so different. They are, but in this situation, you can treat them the same, okay? So the inside is the same exact multiplication, right? -4 times 2 square root of 3. So that would be -8 square root of 3. And hey, we'll be able to add those together. And then lastly, we've got basic multiplication. -4 times -4, that's a positive 16. Don't get that one wrong, right? Okay, any questions about this before I keep zooming along? Okay, we're going to work on simplifying these. So look, the square root of 9 is just 3, right? We can all agree on that. 3 times 3 is 9. Square root of 9 is just 3. So I'm going to multiply that by 4. That gives me 12. These two radicals can be subtracted together. They've got the same root and the same radicand, right? Square root and 3 is the radicand. So -8 minus 8 would give me -16 square root of 3. Remember, when you add radicals, you just add, add the coefficients. Well, for this one, you're adding two negatives. 16. Now, on this one, we can add the 16 and the 12 together, and that gives us 28 minus 16 square root of 3. Okay? And now look, our brains, I know one of you guys in here, our brains want to see 16 or 28 minus 16. I need to do that first. But this is it. Look, this 16 is attached to a square root of 3. I cannot subtract these together because this 28 does not have a radical. And so our brains see 28 minus 16 and go, hey, that's 12, right? But wait, no, it would be, what would it be? Yeah, it would be 12. It's 12. No, it's not 12 because the 16 is attached to a square root. Okay. So therefore we're done. This is it. 28 minus 16 square root of 3. Okay. Any questions? That's a tough one, right? That has a lot of steps to it. But these are two good. I'm going to do probably one or two more examples from 7.4 because I want to do one that actually combines up here. So I'm going to steal some from your homework. I'm going to look into it and see if I can find one. Any questions before I just do a few more from 7.4? Okay. If you've got one, just let me know. You can raise your hand or put it in the chat. No big deal. So let's do. Oh, let's see here. I'm going to steal one from this. We'll call this number 3. I'm going to steal this one from the review. Cube root of 54 y to the 4th minus y cube root of 16y. I think that we might have done this one earlier, but I want you to try this one. Try this one real fast. I'm going to give you a little bit of time. I might put another question up here too. Give you about 5 minutes. And it's not that you have to rush, it's just that we're going to run out of time. And I'm going to search for another one that's multiple. Oh, let's do a basic multiply. Say the square root of 3 times the square root of 6 minus 4 square root of 2. So I tried those two. And I'll give you about 5 minutes, and then that'll give us enough time to go over them before the end of class time. Let's start rocking and rolling. Keep working if you're working, but that way we can get done before class gets out. So the cube root of 54, again, I'm gonna have to break this down. So 54 is, oh, we've done this one a lot, haven't we? Look, I'm gonna be a little lazy here. 27 is 3 times 3 times 3, okay? So it's 2 and then 3 threes. And we're looking for a cube root. So we've got 3 of a kind 3. So we should be able to take out a 3 here. So I'm going to put this over here. So we can take a 3 out. And then we've got a 2 left over. Now I'm going to leave a little gap because look at these y's. I can take a y out as well. 3 goes into 4 one time. So I can take a y out. I'm left with a 2y. I got a little spot here for the 16. So now let's do the other radical. So 16, we know, again, we've done 16 a lot. Turns out it's 2 times 2 times 2 times 2, right? And we're looking for a cube root. So I can take a 2 out. Wait. Oh, yeah, there's already a y there. So it's going to be minus 2y cube root. Oh, no, I'm running out of room. 2y, okay? And on this one, we can subtract these together. These have the same radical, right? They've got the same root, the 3, and the same radicand, 2y. So therefore, I can just subtract the coefficients. 3y minus 2y is going to leave me with 1y, cube root of 2y. Okay? 1y, cube root of 2y. Questions about that one? Comments, concerns? Okay, one more. Let's do this one. So we've got a multiplication. First off, I can't add these inside the parentheses, right? Parentheses mean we need to do this first, but I can't subtract these because we've got a 6 and a 2 as a radicand. So they are not going to subtract together. So then I'm going to multiply the square root of 3. Now, when I do that, remember multiplication, you just multiply under the radical if you've got the same root. And all 3 of these have the same root. So this becomes the square root of 18, right? Square root of 3 times the square root of 6, minus 4 square root of 6. Okay? So the square root of 18 minus 4 square root of 6. Now, we're not done here. We've got to check to see if these simplify. And 18, I think will, because 18 is 9 times 2, yeah. And then 9 is 3 times 3. That's a 3 here. I know it's hard to see. But I've got a pair of 3s and we've got a square root. So this first radical actually becomes 3 square root of 2 because the 2 is left over there. 6 isn't. 6 is just 3 times 2, right? There's not 3 times 3, 3 times 2. There's no pairing up with the 6s, with the 6. So it's 3 square root of 2 minus 4 square root of 6. Okay. Questions from those last 2? Comments, concerns? Yeah, what's up, Gracie? Oh, you're on mute.
Yeah, I just didn't. I just need a bit more time to write all this down.
Oh, no, I got you. Yeah, I'll give you a little more time. Write that down. We've got a little time.
Okay.
Does it make sense?
Yeah, it makes sense.
Okay. Good. Okay. Here, I'm going to stop. Let me stop this. Hold on. I'm going to stop the recording, and that way we've got that for, and I'll have to put it in your